last few examples, we've got a bigger one with a product and a quotient. So a 2 times v to the 5th times c to the 3rd over a to the 3rd. And all of that is being raised to the 3rd power. So when I look at that, look on the inside first. There's no like terms. There's no v's on top and bottom, c's on top and bottom, a's on top and bottom. So there's nothing to reduce on the inside. So move to the outside, and now we'll see that we've got an exponent to handle. So remember, what does that mean? 2v to the 5th, c to the 3rd over a to the 3rd times another set times another set. And so now I can go straight across. So 2 times 2 times 2 is 8 in your numerator. I've got 5 v's, another 5 v's, and another 5 v's. So I've got 15 v's being multiplied together. I got 3 c's, 3 c's, 3 c's. So that means I've got a total of 9 c's being multiplied together. And then in my denominator, I've got 3 a's, 3 a's, 3 a's. So remember, when I say 3 a's, I'm not talking about 3a. I'm talking about there are a's in a quantity of 3 that are being multiplied together. So I've got 3 a's being multiplied, 3 a's being multiplied, 3 a's being multiplied for a total of 9 a's being multiplied. So if I distributed, the thing that people mess up on is make sure you take that power to the constant as well. So that would have been a 2 to the 3rd, v to the 5th to the 3rd, c to the 3rd to the 3rd, over a to the 3rd to the 3rd, which would give me 8. V to the 5th to the 3rd would have been v to the 15. And then c to the 3rd to the 3rd is c to the 9th. A to the 3rd to the 3rd is a to the 9th. So I still got the exact same answer. All right, so let's try some more basic quotients. I have, a clean piece of paper. 7 to the 12th over 7 to the 6th. That's kind of a funky 12, sorry. All right, so actually let's just rewrite that. 7 to the 12th over 7 to the 6th. So your bases are the same. So how many 7s do I have on top? I've got 12. How many 7s do I have in my denominator? I've got 6. So what I really have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, 2, 3, 4, 5, 6. So any number divided by itself means that 6 sets of those reduce to 1. So I've got 7 over 7 is 1, 7 over 7 is 1, 7 over 7 is 1. So what do I have left? I've got 1, 2, 3, 4, 5, 6 7s left in my numerator. Okay, so what could I have done? 7 to the 12th over 7 to the 6th means I would have had 7 to the 12 minus 6, which is 7 to the 6th. So if my bases match, I can subtract my exponents in a division problem. So I've got 2 to the 15th over 2 to the 11th. So 11 sets are going to reduce to 1, just like 6 sets reduce to 1 up here. And so instead of me writing out 15 2's over 11 2's, I'm just going to say, well, 11 sets are going to reduce out to 1. And so 15 minus 11 gives me 4. So that gives me 2 to the 4th. Now, you actually can take this a step further. Okay, 7 to the 6th is a larger number. So 7 to the 6th power gives me 117,649. So not equal. All right, so 117,649 is that answer. So if it asks for an exact answer or an integer, that's what you're going to want to put. If it asks for it in exponent form, then this is what you're going to want to put for your answer because it has exponents. Well, 2 to the 4th, I know what that is because that's 2 times 2 times 2 times 2, which gives me 16. So that's a small number that my brain is happy with. So I would much rather see 16 than I would 2 to the 4th. In this case, I would much rather see 7 to the 6th than all that trash over there because that's a larger number. But just pay attention to how the question is being asked. All right, so I have 7 squared to the 5th power over 7 to the 7th. So I notice, going back to order of operations, there's nothing to be done on the inside. Well, I could make that a 49, but I'm going to tend towards not, because I notice that I've got the same base here and here. So it's probably going to waste my time to change this into a 49. So what I can do is recognize that, yeah, there is something to be done in the parentheses, but I'm leaning towards not dealing with that yet. So now move outside your parentheses, and grouping symbols say I can do the numerator and deal with that as a separate thing over my denominator and deal with that over a separate thing. So now my question is, what does this 5 belong to? And it only belongs to the stuff in parentheses. It's glued to the parentheses. So if I've got a power to a power, that's going to give me a 7 to the 10th, because you've got 7 squared times 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 7 squared, which means you have a total of 10 7s being multiplied together. And now that's over 7 to the 7th. And now your bases match, so you can subtract your exponents. So 10 minus 7 is 7 to the 3rd. So when I do that, either my answer is going to be 7 to the 3rd, or it's going to be 343, just depending on the answer. So if it asks for it in exponential form, you're going to put 7 to the 3rd. If it asks for an integer or a simplified fraction, you're going to put 343. All right, I have 27 y to the 9th over 9 y squared. So I can look at this as two separate things. So I've got a 27 over a 9. Well, 27 divided by 9 is 3. It is not 1/3. Okay, so it's the same thing as saying 9 times 3 over 9. So any number divided by itself is 1. So that leaves me with a 3, and then I've got 9y's being divided by 2y's, or y to the 9th divided by y squared. So that means I can subtract my exponents and get 3y to the 7th. So let's do it again. I have 6y to the 5th over 6y squared. So I can look at my 6's. Any number divided by itself is 1, so I'm not going to bother writing the 1. I'm too lazy for that. Okay, but a y to the 5th over a y squared, my bases match, so I can subtract my exponents, and I end up with a y to the 3rd. All right, I have, hang on, I'm flopping my papers. I have a 30x to the 8th over a 35x to the 7th. Okay, so this one is a little bit different because this is an improper fraction. I'm sorry, what did I just say? This is a proper fraction. Okay, this one was improper. So my numerator was larger than my denominator and it divided evenly, so I got an answer of 3. This one was just a fancy way of writing 1. So any number divided by itself is 1, and I'm too lazy to write the 1. Well, this one isn't going to completely reduce. So what I should probably do is look for similar terms. So what can I break 30 down to? I could break it down to 1 and 30, 2 and 15, 3 and 10, or I could do 5 and 6. Now I've got x to the 8th. So let me tell you why I chose 5 to the 6th. What can I break 35 down to? 35 is the same thing as 1 times 35, or it is 5 times 7. So I was kind of sort of looking ahead and trying to find common factors, and in this case my common factors are 5. So that leaves me with a 6 over a 7, and now I can write this one of two ways. Okay, so I've got x to the 8th over x to the 7th, which means I could have just an x to the 1st sitting here. So remember we did this before, where we were looking at how can I write fractions. So I can either write 6/7 times x, or I can write 6x over 7. Both of those are correct. Both of those are correct. What is not correct? What is not correct is saying 6 over 7x. That is not right. Your x has a positive exponent, so he's either going to be considered as over 1, so he's up with the numerator, or you can just write it out to the side. So either one of those is correct, but do not put that thing in the denominator. All right, I've got a negative 10, x to the 6th, z to the 5th, and then I have a negative 2, x to the 3rd, z squared. Okay, so I'm going to look at my numbers first. my constants, my coefficients. All right, so a negative 10 divided by a negative 2 gives me a positive 5. Positive 5. Now compare your x's. I've got x to the 6th over x to the 3rd, so I can subtract, and that gives me an x to the 3rd. 6 minus 3 is 3. I've got a z to the 5th over a z squared. So that means I subtract my exponents, and I get a z to the 3rd. So there's no fractions left because everything is just over 1, and I'm too lazy to write the over 1s. So that is my final answer. And that is it for this section.